Hello, here's another integral that may or may not involve inverse trig. That's one of the tricks here is to, and one of the, I guess, challenges is to figure out how to integrate this and what does apply. So this is the square root of a quantity involving x. So like you can think of that as u minus a constant. So the square root and the difference tells me that it may be an inverse trig function. So this, knowing your formulas or having them in front of you, this looks like it may be an arc sine or maybe an arc secant. So when you look at the formulas, the u is the x. So it's not an arc sine. It might be an arc secant. However, this arc secant looks pretty complicated. It has a u out in front of the square root. So could this possibly be it? Well, I'm not so sure. The e to the 2x is a kind of a funny thing. So let's see what we can do here. Let me copy this. It's definitely not an arctan because there's no square root and it's a plus. So I'm thinking it may be an arc secant. Now, it may be none of those, and there might be a different way to do this. But we'll see. Sometimes you just, as usual in integration, you just have to try something. Now, e to the 2x, think of as e to the x squared. So that could be this part of it, the u squared. So that would mean u is e to the x, which also means du is e to the x dx. So if you look for your substitutions here, we have the square root of u squared minus a squared, that's 1, and dx would be du over e to the x. Now, I don't like that e to the x there because it's an x, and we're trying to do this with respect to u, but you know e to the x is u. So it looks exactly like this, which is exactly what the arc secant formula looks like. So this is a good example of an integral that is not very obvious about what's going to happen at first, but when you actually go through the u substitutions, you may run into something. And we've just rammed into the arc secant formula, and it's perfect. It's the exact formula here, and we can now just apply the formula. This integral would be then 1 over a, and remember a is 1 here, 1 squared is 1, times the arc secant of the absolute value of u. Our u was e to the x over a, which is 1. So I'm going to simplify it a little bit, obviously. We don't need the over 1s. But another thing is the absolute value of e to the x. E to the x is always positive. It's an exponential function. So the absolute value of a positive number is pretty redundant. Doesn't do anything to a positive number, so you don't need the absolute values, and this would be the final answer. So that was a nice one. I'll see you on the next one.